Hello friends, my name is Rajendra and in this session I can teach you how to find the factorial of a number using recursion technique. Okay, so using recursion it will basically do a task very easily with a very few of line of codes. Okay, so recursion is very important. Come on, let's start it. Suppose, okay, yeah. And I can solve this question basically in JavaScript. Okay, so don't mind. You can also solve this in C++, Java at all. So only the syntax are different and the logic is basically the same. So first of all, let's start it. What is factorial? Okay, so the first thing you have to keep in mind that the factorial the factorial of 0 is equals to 1. Okay, and factorial of 1 is equals to 1. This two thing that you have to keep it in your mind. Okay, and come on, let's move further. And okay, so where I am, yeah. So suppose if I have to find a factorial of let's take a smaller example like 3. Okay, okay. So it's a 3 factorial. So how we will find this? Okay, so we have to do is that 3 multiply by, then the smaller number of 3 will be 2 multiply by 1. Okay, multiply by, if we suppose if we write here 0, then it is basically a 1. So 1 into 1 is 1. So let's neglect this. Okay, if you want to write it, then it's not a big deal in there. Okay, so uh, what basically we want 3 factorial into 2 factorial into 1 factorial is equals to what is 3 into 2, 3 2s are 6, 6 ones are 1, 1 6 ones are 6, and 6 ones are 6. So basically the answer is 6. Okay, and with the help of recursion method, so I can also say that 3 multiply by this this pending box is basically the same answer. So 3 multiply by, you can also write it here, where it's not mandatory to write it, it's just because of explanations. Okay, so 3 into 1. So basically, what I am trying to explain you, just listen carefully. 2 into 1 is equals to, basically we get 2, and then 3 multiplied by 2 is equals to 6 only. Okay, I can I can tell you basically how we can solve the equation with the help of a recursion. Okay, okay, yeah. and and one more thing. Suppose if I have 5. Okay, suppose, so what we will write? We will write 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So we can also say this 5 multiplied by this whole equation. So basically 4 into 3 into 2 into 1. If we get this answer, then we can multiply by this answer, then we will get the answer. So basically, we are finding here answer. So 4 into 3, no, it's we can do it like here 1 into 2, 2. 2 3s are 6, 6 4s are 24. So it is 24 multiply by 5 is equals to multiply by 5, not 51, it's 5. Then we will get the 120. So this is the answer. Suppose uh, uh, this is basically, suppose a function. In a function I can pass this 5. Okay, suppose this is a n, suppose this is a n, so I have n is equals to 5. N is equals to 5 basically means that we are finding the factorial of 5 number. So we can say that, suppose, okay, let's, let's solve this question with the help of accelerator, and I can solve this in JavaScript. So do not mind. So what I have to tell you, I have to tell you that, suppose if I have a n, so let's, I am basically solving this in JavaScript. You can also find it any program language. So I have function and then factorial. Factorial, and in that basically I'm passing one parameter which we can assign to it and on whatever name you want to give, you can afterwards. Basically, to solve the problem of recursion, basically first we will want the base case. Okay, I can explain you the very. So we get the n, and suppose if I am returning here n multiply by something, something means n multiply by, basically this is the n, so I have write it down over here, n that I know, and multiply by this. So we do not know that how we get this answer. Okay, so what we will do is that, suppose a function inside a function, suppose this is a function, this is the value of n. In the function I am passing n. In a function basically this is a function. In this function I know what the n is, so I have passed that value n, and and yeah, this is the next function, we can also say it 3. Let's do 3 4 into 3 into 2 into 1. So this was our first function, and then we are calling the sec, in the whole loop we are calling the second function, which is 4. So we can also say that here I am writing f of factorial of n, because I have named it there factorial. Suppose here I can tell f now, so I can write it f factorial of n one more time. But if I am writing factorial of n one more time, then we will get 5 only. Okay, so what we have to do, this value is 4, so n minus what we have done, then we will get this 4, n minus 1 basically we are doing here. So if I am writing there n minus 1, and then here I am writing n minus 1, then we will get 4. Okay, so one more time the function will call, one more time the function will call, and now here we will, suppose we will return in uh, Okay, we will written here 4. Now in a function the value is 4. Okay, the value of 4, and then we will multiply this one more value. So here only in a function we are putting this, and here only one more time this will go n minus 1. N minus 1 is 3. Okay, so yeah, n minus 1 is 3. So it will take one more function here. It will take one more function, and now the value of n is 3. Then it will return, and n will return 3 multiplied by one more function. One more function which is n minus 1. The loop will be go like this only. Okay, and this function will call a one more function f of 2. F of 2 which is return f of 2 will return what? uh, 2 multiply by 2 multiply by what? One more function, and this n minus 1, n minus 1, and here we will get n minus 1 is nothing but 2 minus 1. Yeah, it is 1. And then it will carry calling one more function like f of now this is 1. So f of basically 1, and here this is a function, and it will basically return 1 multiplied by 0. Now here you have to think what I'm trying to explain you. Now what is it will 1 it multiply by 0. Okay, and and wait, I can explain you everything. Yeah, so this will here now is 0, n minus 1. Basically here not 0, it's one more time to function of n minus 1. So here the n is 1, so 1 minus 1 is 0. Now then it will call f of 0, f of 0. So it will go further. It's like a while loop. In a while loop, basically we can't give a condition. So while loop is looping, iterate one after one. The condition true, it will iterate, it will iterate, it will iterate. So it will move further only. It will not stop. So we have to stop this loop. Suppose here f of 0 is nothing but it will return retu. It will return what? 0 multiply by one more function f of n minus 1. Now it is 0. 0 minus 1 is minus 1. So in a factorial, we cannot multiply it by minus 1. We just cannot multiply it negative number. So what? We have to give a condition, and that condition is known as a base case in recursion. So it's mandatory to give a base case in recursion. Otherwise, the function will go inside a function, we go inside a function, and there is no end of that function. Okay, so there is no end of that function. So we have to give a condition. Now, what condition is here coming on your mind? See, I have tell you 5 into 4 into 3 into 2 into 1 into 0. 0 is nothing but a 1. So if we looked at 5 multiply till that 1, then also we will get the same answer. Okay, so here the base condition is basically in a function. I can tell you to keep this in mind. So what basically the base condition is if and here basically the n is coming now. Base if n equals to 0, then return return what? Then return 1. Then return 1 because the 0 is 1. So basically we can tell it return 1. The answer 1 basically we got. Okay, so here the 1 will come, and then if this condition is satisfied, if the condition is satisfied, and then the one of your loop is going to f of, suppose here we will get f of 0 minus 1 is minus 1, so f of minus 1, and then in a function, actually this condition, where I can tell you this condition we will give here. If suppose if this n equals to 0, then return 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 1. Okay, so if this condition is satisfied, then we have to we do not move further, just stop the loop here and come back. So our journey started. So our journey started from here to here. If we cannot stop this loop, then it will give further, 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 and we will not get the answer. And so we will not get the answer. Okay. So this thing you have to keep in mind. So we have, it's mandatory to write a base case, and then it is minus 1. So basically here we have condition if n equals to 0. So here the n is minus 1, it is not, condition is false, then it will not move further and it will go back. It will go back. So 0 into minus 1 is nothing. Here we get nothing. So 0 into 1, 0 is multiplied by anything, we will get a 0. So here the value we will get 0. Okay, so return 0. So here basically we get 0. Okay, nothing but 0. So here, uh, if n is equals, yeah, if here the condition is stopped here, because the n is equals to 0. Here the n is equals to 0, it will not move further. This n is equals to 0, then we will get 1. So here 0 is 1. Okay, then it will come in this loop only, f of 1. So 1, so here 1 multiply by this function. In this function we will get one answer. So 1 multiply by 1 is 1, and then it will come here. So 2 multiply by 1, basically we get 1, not 2. 2 multiply by 1 is what? 2 multiply by 1 is 2. Okay, so in this function we will get 2, and we will come here. In the function we will get basically 2, value of 2, and we can say 3 multiplied by 2 is what? 3 multiplied by 2 is 6. So in this function we will get 6, and then we can say 4 multiplied by 6 is what? 6 fours are 24. So in this function we get 24, and then we will move further. So here 24 we will get. So here basically the function of n minus 1. So here the n minus 1 we will get 24. So 24 multiplied 5 is 24. And like this only we will get this answer. Okay. So let's code it. Okay. So let's code it. So I can tell you that in a function, in a recursion function, we have, it's mandatory to write a base case. Okay. So I am writing the base case. What's our base case is n equals to 0. Then basically return, return what? Return 1. Return 1. That's it. Afterwards, here we have, in a function, basically this is a function, and in a function we are passing one more function, which is factorial factorial. Oh my god, my piece is lagging. Just wait. Yeah, factorial. Factorial. Yeah, it's right. N minus 1. So first time here it is 5. Suppose let's take an example. Here is any number. If any number is greater than 5. Suppose here is 5. Then here will be 4. Then after 4 into 3. Then 3 into 2. 2 into 1. 1 into 0. If 0, then it will stop and move. Okay, so it was going up to down and down to up, and here basically we will get the answer. Okay, So let's console it. What I have console in here? Factorial of you are a yeah. Factorial of let's find the answer of 15. Now let's see what we will get. It's interesting. Oh, I got yeah. I got 120. So see here it is 120. So we will get 120. So answer is right. 120 multiply by what? Multiply by 6. Then we will get basically 120 into 6 is nothing but 132, I guess. So write it here 6 and let's see. Oh, it's 720. Okay, 120 multiplied by 6 is 720. What? 122. Yeah, it's 720. So we get 720. If you not understand that how 720, let's use the calculator. So it's taking lots of time. My piece is lacking. Just wait a moment. Yeah, so what we will get? 120 multiplied by 6. Let's see what. It's 720. Yeah. Let's take another example. No, I can. Yeah. So 6 multiplied by 120 is equal because 6 12s are 72. So one more 0 is added. Okay. Yeah. So recursion is basically a tough language. I can. This is very simple example. We can say it's from basic to understand how the function inside the function inside a function is working, and it's very good example. And there are twice two functions are there. There are three functions are there. So there are lots of stuffs are there basically. So this is the first. If you so this is the one example. If you like this movie, so please write on the comment that if you understand this, then write that nice explanation. And if you don't want to subscribe, you can. It's all up to you. I'm not teaching you for the subscriber. Yeah. So thanks for watching me, and that's it for the video. See you next.